Yes, class. Good evening. Am I audible? Hello. Priyadarshini, Rifat, Sahal.
Yes, ma'am.
All right. Samia and Bhavya. Okay, class. So in the last class, we had completed with this average and mean value of alternating current. Let's start with your phasors. This is one of the very important topics, and this is the core part of your AC circuit. When you will understand this, then automatically LCR circuit you'll be able to do, and maximum part of this lesson will be covered. See what is meant by phasor and what is meant by a phasor diagram. Phasors you have to understand. See, a rotating vector that represents a sinusoidally varying quantity that is known as phasor, and phasor diagram's definition says that a diagram that represents alternating current and voltage of same frequency as rotating vectors or the phasors along with a proper phase angle between them. See now what is meant by this. This vector that we are referring to, this rotating vector, this is just imagined to rotate with angular velocity, which is equal to the angular velocity of the quantity. We represent phasors in this way. See, phasors are just rotating vectors. You have current, you have potential, you have various quantities, physical quantities that exist. Now, if you want to represent it graphically or with the help of diagram, so that quantity we call it as phasor with the help of diagram. Just now see, for example, this is just a representation of the graph in circular manner. Now, if I draw voltage, I am depicting that this is the value of voltage. Let's say E naught. E naught is the voltage in this. So this pointing arrow is pointing towards a certain or specific value of E naught. Now, if I draw current over here, this is current, peak value of current. So using this diagram, the circular part, you will be able to analyze this, that the current is leading, the current is in front of this. So we are able to analyze regarding the frequencies, proper phase angle. You will be able to actually get the phase angle between these two, as well as you will be able to obtain the phase angle with respect to the x-axis or the y-axis. Now, since these vectors will rotate if you keep on drawing them, if you keep on expanding their value, sometime it may happen that they are pointing towards here. It may happen it is pointing towards here. It is pointing towards here. So what will happen? The pointer will keep on moving and rotating. That's why we say these are rotating vectors. Do not consider it with the normal physical quantity vector that you have. This vector is different. This means it has a direction, it has a magnitude, it obeys the vector laws. This is not meant by this. Potential, voltage is a scalar quantity. Current, we've already discussed in current electricity that it is a scalar quantity. So do not go through this. We have just named this term as a rotating vector. Rotating vector is simply just showing that this is rotating and you're able to analyze facts from this. When we'll do circuit, right now we'll start with circuit containing only AC. So that there you will be able to observe from here you will be able to observe the information and the detail about the graphs that you have. Now see what will happen if I give you this diagram. So even without calculations, even without the formulas, you will be able to derive the fact that current is leading voltage. If somehow I interchanges, I write voltage over here and current over there, then you will be able to analyze that voltage is leading. So these are just diagrams to represent it, and these are helpful to just gather information. And since these are rotating, we call it as rotating vectors. Now see, phasor is what? These are now known as phasors. So a rotating vector that represents sinusoidally varying quantity, because we have studied alternating current and alternating voltage always vary sinusoidally. And phasor diagram, this diagram is known as phasor diagram. It depicts what? Alternating current and voltage. Frequency is same with a proper phase angle between them. This is what about phasors. Before we start with the AC circuit containing resistor, note down till here. Then we'll do further. Sinusoidally means having the sine curve, the curve that we had seen in case of EMF. Let me show you. Just a second, class. This curve, that we get, no, this wave curve, that is known as sinusoidally. If you get sine in your equation, then your graph becomes like this. This is known as sinusoidally. So since in alternating current and alternating voltage, we have the variation sinusoidally, that's why we write it. Done?
Yes, ma'am.
Now see, we are going to study registers. We have studied equivalent combination of registers also we have calculated, but that was DC current when you had. Now we are referring to AC current. When you have AC circuit containing only resistor, so here you will not be having a proper battery. Your AC dynamo will rotate the coil and the alternating current will flow in your circuit. Now here just a resistor is connected, no inductor, no capacitor, any other no other device. Now so this type of circuit, when you have only a resistor connected along with an AC dynamo, we call this type of circuit as a purely resistive circuit. So in the exam you can get a direct question on purely resistive circuit, or the whole definition can be written AC circuit containing only resistor. So a resistance of this resistor is R, and this is E naught sine omega t, potential alternating EMF. So E is E naught sine omega t, which is instantaneous value of it. Now, if you apply Ohm's law, V is equal to IR, here Ohm's law will be E is equal to IR. What is the value of E? E is E naught sine omega t. This is equal to IR. Transport this. See, E is equal to E naught sine omega t IR. From here, if you write the value of current will be equal to what? Current will be equal to E naught sine omega t divided by R. Now, E naught by R, E naught divided by R, this is basically current. See, E naught divided by R. This is your peak value of current. See, I naught, E naught, R. How will you relate these? Using Ohm's law, you can relate it by this relation only. So from there, I naught will be equal to what? E naught divided by R. So E naught divided by R, this is I naught. So what's the equation that we get? Equation is I is equal to I naught sine omega t. So E was what? E was E naught sine omega t. I is I naught sine omega t. So do you see the phase? There is no phase difference. The value of E naught is replaced by I naught. There is no phase difference between them. You cannot see any angle addition or any angle deletion. It doesn't say E naught sine omega t plus 60 degree or something. Both are in the same phase. So always remember, see class, this topic now that we will finish today. This is a very basic topic for your alternating current. If you will understand this, understanding LCR circuits will become easier, and the whole chapter is based on this only. So this is within the same phase. Now, if you have it in the same phase, how will I draw the graph? See, suppose I want to show it with the help of graph. So let me show first. Let me depict value of EMF, let's say. So EMF will be varying sinusoidally like this. This is what? This is EMF value. And there will be a peak value of it, which will be E naught at this highest point, this point. And then you will be having a value of current. Current will be what? If you have a peak value of current. So current will also start from here. It can happen current's magnitude is lower. Current's magnitude is lesser than the value of EMF. But this you are getting, this is current. And the peak value, this maximum value that you are getting, this is I naught. So this is what? This is simply E naught graph versus the time graph. So here you can see there is no phase difference between them. This is showing what? This gap is showing you that both are in the different, they both have the different magnitude. The maximum value of E naught is this, maximum value of I naught is this, both magnitude is different. But phase, you can see both are in the same phase exactly. This gap is showing the magnitude, but there is no phase between them, no phase difference. If there would have been any phase difference, I would have started current from here. I would have started EMF from here. Fine, this is just the difference that is coming. Now, even if I want to show it on the phasor right now only, no, that we have studied. See how will I show it? Both are exactly in the same phase. So EMF will be here. Let's say EMF is here. So current will be where? Current will also be in this phase only. This is just giving you the difference in the magnitude because it can happen, both do not have the same magnitude. Even if you want to know what is this point, this might be your I naught sine omega t, whose value we have already calculated, and this will be E naught sine omega. So what do you have to remember? See, even if you remember this, no, this graph, by looking at the graph, you will be able to figure it out. Yes, both are in the same phase, so it will be I naught sine omega t, E naught sine omega t. Rest of the details you don't even need to go through. So do make these graphs properly, and I would suggest you all to draw it with two colored pens. If you have black and blue, if you can keep, or if you can keep a pencil with you, just have two shades with you so that you will be able to distinguish it. Because once you will be revising for the exam, things will get messed up. So first point that you have to remember in circuit containing only resistor is the value of EMF and the value of I, that is E naught sine omega t, I naught sine omega t. Simply this shows that there is no phase difference between them, no angle between them, so both are in the same phase, and that is depicted through the phasor diagram as well and through a simple graph as well. Normal graph of E versus T and phasor diagram for a resistive AC circuit. Note it down till here, then we'll start with an inductor circuit. Now class, let's start with circuits containing only inductors. So resistors we had seen. So this will be a circuit that is containing only an inductor. E naught sine omega t will be the potential EMF that it is containing, variable EMF that we are having. And the inductance of this inductor is L. So that's why in the last lesson when we were doing electromagnetic induction, we had covered the phenomena of self-induction as well as mutual induction. Now inductance is over, all the topics of EMI will be repeated. So that's why please revise. You have already given the test of EMI. Yes, no? You have, in the last class you gave the test of EMI, no? All of you. Fine. Now see, E is equal to E naught sine omega t. And E is equal to minus L di over dt. This is according to the formula that we had derived. Derivation of this comes, please mark it from your EMI lesson. There we had done the derivation, how this has arrived. From phi is equal to Li, you have to start, magnetic flux will also come. Now, if E is equal to minus L di over dt, this is differentiation of current with respect to time, put value of E. This is E naught sine omega t is equal to minus L di over dt. From here, if you keep di over this one side and you transport dt and L on the other side, you will be left with di is equal to E naught by L sine omega t dt. Now, I'm not considering this negative sign as we have repeatedly discussed this fact that negative sign is just depicting you the Lenz's law. Right now, we are finding out the magnitude of it, so no need to write the negative sign. di is equal to E naught L sine omega t dt. Now simple differentiation and integration is used over here. Right now we'll integrate it. So integration of di. If you integrate di, ultimately you will get I only. And here E naught by L, these are constant terms. So E naught by L, you can take it out. And sine omega t. See, sine omega t will be what? This will be cos omega t divided by omega. That will be the value of this. Keep this together. E naught by omega L together and write cos omega t. So E naught by omega L cos omega t has been kept together. E naught by omega L. This term, I'll emphasize this, we'll discuss this later on. First, just let's derive the formula for it. E naught by omega L is the peak value of current over here. So you can write this equation as minus, or you can simply, okay, one negative sign will also come, no, because sign has been integrated. So this becomes minus I naught cos omega t. Let's eliminate this negative sign. Minus I naught omega t is coming, no. Let's use some identities and equations to eliminate it. So if you use the equation, this trigonometric equation, cos theta is equal to sine 90 minus 2, sine pi by 2 minus theta. If you use this, so that this negative sign could be eliminated. So firstly, you will get what? Instead of cos theta, you have cos omega t. So you will get minus I naught sine pi by 2 minus omega t. Now, one more identity we will use to eliminate the negative sign. Now we can use, because we have sine with us now. So minus sine theta, this gives you sine of minus theta. All right, see, there's a difference. Minus sine theta is equal to sine of minus theta. In the second, on the right hand side, we have the negative angle with us. And on the left hand side, you have the whole trigonometric function differently. So minus sine theta is equal to sine minus theta. So what can we write? Now we can replace this minus sine theta as what? See, equation I. This becomes equal to I naught. Now this you can interchange, because this has become plus, this will become minus omega t minus pi by 2. And this sign will also be there. Sign. So this Final formula of current is this. But what was the value of E? If you remember, E was equal to E naught sine omega t. E was equal to I naught sine omega, E naught sine. So in the last case, when we were discussing resistance, what did we notice? In case of resistance, I was equal to just I naught sine omega t. You had this part only. Here you have additional pi by 2. So is there a phase angle according to you all or not? Yes or no? Compare both these equations. Amin, Madiha, Priya. Yes or no? Do you see any phase angle? How much are you able
Yes,
to
ma'am.
see?
Pi by 2.
Pi by 2. Okay, one more thing. Can you tell? Do you think current is leading or EMF is ahead? Which one is leading? By just looking
Current.
at the current is leading. See, uh, now what we'll do, E is equal to E naught sine omega t, I is equal to I naught sine omega t minus pi by 2. So as rightly answered by Madiha, pi by 2 is the phase angle. See, I naught sine omega 2, had it been I is equal to I naught sine omega t, this would have been depicting the same phase. Now this is minus pi by 2, means your current is lagging by 90 degree. So you can say voltage is ahead. Minus pi by 2 means current is lagging by pi by 2. It is pi by 2 behind EMF. That's why you have a negative sign. Otherwise, you would have got a positive sign plus pi by 2 if it would be leading. Now, so I, E both are present. This extra part that we are getting minus pi by 2, this is just depicting the fact. Firstly, pi by 2 is the phase angle. Minus sign is showing what? Minus sign is showing that this is lagging behind. So here the values will change. Now we had stopped at this point 1 E naught by omega L. We didn't discuss what was, how did this omega L vanish, and we had replaced I naught just simply. So the reason behind this is that I naught is equal to E naught by omega L, and when you multiply omega into L, you get a constant resistance that you call it as XL. And the value of XL is, this is known as inductive reactance. This is known as inductive reactance, omega into L, angular frequency multiplied by the inductance value. In order to just concise this, so I will be equal to what? I naught will be equal to E naught divided by XL only. So XL is simply just the resistance work that is being done. You can compare it with Ohm's law also. In Ohm's law, you had current is equal to voltage by resistance. Here also the work that the resistor provides in a case of purely resistive circuit, the same work is done by the inductive reactance in case of a purely inductive circuit. All right, class. Did you understand till here? Yes or no?
Yes, ma'am.
Apart from Emin, others?
Yes,
Samia,
ma'am.
Bafia?
Yes, ma'am.
Okay. All right. So now see, what is this inductive reactance? The definition of inductive reactance is simply, it's the measure of resistance or opposition that is offered by the inductor to the flow of AC fluid. Whatever work the resistor is doing, no, in a normal DC circuit or a AC circuit containing only resistor, same opposition work is done by the inductive reactance in case of the circuit containing only an inductor. The same opposition work, the same resistance work. It's just that product of angular frequency and inductance is known as inductive reactance, and a new term has been defined. X with an L in the subscript. So omega, you can expand this as what? You can expand omega as 2 pi nu, where nu is the linear frequency. XL is equal to omega L, and omega, you can write it as 2 pi nu. So if in the question linear frequency is given, so use this, convert using this relation, and then solve the further answer. Now you can see one more thing. From here, XL is directly proportional to frequency. So if your XL is directly proportional to frequency, graph between XL and frequency will be a straight line. And XL is 0 for DC. This you can remember this point. XL is 0. There is no inductive reactance for DC. Why? Because there is no alternating voltage or EMF. There is no concept in DC current that we study. This graph comes in your exam. This is a very easy graph, but this comes in your exam. Most of the previous year's papers have asked this question. The graph between XL and frequency. And one more graph we'll do, that is the graph between omega C. XC we'll do in case of the capacitor. So voltage is ahead of current by 90 degree. This is the final conclusion by it. Now see, if we have to draw this, if we draw the graph between these, the way I had drawn the graph for the circuit containing only resistor, if I draw a graph over here, see, this is your omega t's value, this is EMF and currents graph. Now I am first writing voltage is ahead, voltage is leading current by 90 degree. So now the graph will directly start from here. This is showing you, see, I didn't start it from the origin because this is already leading by pi by 2. When the EMF, this is EMF and this must be certain value of it, maximum value. Now when the EMF was at its maximum value, that is leading by pi by 2, current would have started its journey. Now the current is initially, its initial stage, while the EMF has leaded. EMF is leading. So this value will be I naught. Again, do not go by the gap or the magnitude of it because it is just giving you the magnitude. Main concern is voltage is leading. Even if you wish to draw this in the phasor diagram, see how will you draw it? Phasor diagram will be drawn. See this, these will be the axes on the phasor diagram. EMF is leading. So somewhere here the EMF will be. Let's say this is the value of EMF because this is leading. So where will the current go? Current is still lagging behind. So current will be here. So you can easily see the phase difference between these two. You can easily notice this is 90 degrees. So EMF is leading current by 90 degrees. Otherwise, they were in the same phase when you were dealing with circuit containing only resistance. Is this clear or not? Yes, Rifat, Sahal.
Yes, ma'am.
All right, note it down. If anybody has any doubt from any part, let me know. I'll repeat it or I'll clear your doubt. This derivation also comes. One or two these trigonometric identities are also used. Please remember this. Then we'll do the circuit containing only capacitor. Done, class? Shall we start with the last part? AC circuit containing only a capacitor. Now see, from the next class, you will be able to manage because LCR circuits are just based on this. So AC circuit containing only a capacitor. Now see, capacitance of the circuit is C. Here the potential or E that you say, this is E naught sine omega t. Potential, charge and capacitance, how these three are related with each other? Yes, class. Potential, charge and capacitance, how to relate these? Answer: charge, potential and capacitance. There's a single formula to relate all these three. What is it? Rifat? What's the formula? Charge, capacitance and potential. Priya?
C equals Q by V.
Yes, C is equal to C. Directly you can say Q is equal to CV or C is equal to Q by V from here. Good, sir. So this is one relation that will be used. So Q is equal to CV. You can directly say. So C will be equal to what? C epsilon naught sine omega t. This will be the charge that will be present. Now, if the charge is C E naught sine omega t, current is what? Current will be dq over dt. And this is dc e naught sine omega t over dt. Differentiation of this. Now, once you will differentiate this, what you will get? C e naught will be there. And this will become cos omega t. And the constant omega will be multiplied. This is what you will get. So I will be equal to what? See this, omega c e naught cos omega t. This will be what you will be left with. Now see here in this case, this term that you are obtaining, this is acting as the I naught. So I will be equal to I naught cos omega t, or you can write directly. You can write this as what? I naught sine omega t plus pi by 2 by the identity. So equation that we have obtained, this is the equation that has been obtained. And E was E naught sine omega t. So both are not in the same phase again. Pi by 2 is there, but this is a plus sign. It means this time current is leading the voltage. The current is at the lead. This is leading the voltage. E naught sine omega t. Now let's talk about this term omega c E naught. Omega c E naught was referred to as I naught. So if we replace this using Ohm's law, Ohm's law is what? V is equal to IR. Multiply this, E naught will be I naught by 1 by omega c. Then only, no, this will go up. So that you will get 1 by, this is in the denominator as omega c. This is in the denominator as omega c. Now, if I want to substitute this, if I want to write this I naught, I can write this I naught also as E by omega c. Now, if I write this 1 by omega c, what will happen? E naught by 1 by omega c. If I want to write it, omega c will go up and you will ultimately get the value. This will go up and you will have the same value, E naught omega c. No difference. So it means I can write I naught as E naught by 1 by omega c. This 1 by omega c that you will obtain, this is known as Xc, which is the capacitive reactance. So you can write the equation I naught as E naught by XC. Same story, same thing. Everything that you've studied is similar. XC is the capacitive reactance. It's the opposition offered by the capacitor. Whatever work the resistor was doing in resistive circuit, whatever work inductive reactance was doing in inductive circuit, same work is being done by the capacitor in capacitive circuit. And C, Xc is equal to 1 by omega C. So even if you write the value of omega as 2 pi nu, Xc and frequency here are inversely proportional to each other. So the answer that you will obtain, this will be inversely proportional. So this difference also comes in between Xc and XL. So there you have to mention that frequency and Xc are inversely proportional to each other, while XL and nu were directly proportional to each other. So this is just a conclusion. To write this conclusion, you can just study. You can note this for your revision. See, just a quick revision of what we have studied. Circuit containing only resistor. E is equal to E naught sine omega t, I is equal to I naught sine omega t. E and I are in the same phase, I naught is E naught by R. Fine. L is E is equal to E naught sine omega t, I is I naught sine omega t minus pi by 2. It means current is lagging by 90 degrees. And you can write E naught by XL as current's value, where XL is written as omega L. Capacitive circuit, just now we did current's value is I naught sine omega t plus pi by 2 is additional over here. This shows that current is leading because there's a positive sign, and I naught will be XC by 1 by omega C. One more thing. The graph and the phasor diagram. Let's just include that as well. See, this time the current is leading. So the diagram of current will start from here this time. And the graph of EMF will be 0 when the current will be at its maximum value. This is EMF, whose peak value is E naught. This is current, whose value must be I naught. Now, even if you want to draw up the phasor diagram, see how the phasor diagram. Phasor diagram will have all the details, and you can just revise it from the phasor. Once you will study this chapter, and please be prepared for this lesson. After the completion of that lesson, after one class, you will be immediately having a test. Please be prepared. EMF, let's say EMF, current, let me draw current first. See, current, let's say current is here. This is current, I know. EMF is lagging by 90 degrees. This time EMF, this will be drawn here. This is your EMF. And now the angle between them, this is 90 degrees. This is what is the difference between all of these circles. Understood? Okay, one more thing. IRMS, this we have studied. IRMS is equal to I naught by root 2. If you write the value of I naught, that is E naught by 1 by omega C, from here what you have studied, E naught by root 2 will give you ERMS. So same thing, IRMS, when you have IRMS, you will be using ERMS. When you are having I naught, you will use E naught. Fine, these are the basics thing that will be the same. That's a one line I had added if anybody forgets it. So note it down. This was one more major portion of alternating current that we have covered today. Now understanding of LCR circuits and other circuits will become easier only if you study and revise this. Please class, it's a request, when you come to the next class on Tuesday, revise at least this. I'll ask you questions orally from this. This time one test that I'll take, that will be a Viva. Now note this down. Any difficulties, any queries you have, you can ask me.